Hey y'all, Professor Wyman here, and in this video I'm going to show you how to calculate Pearson's correlation, Pearson's product moment correlation, or Pearson's R, whatever you like to call it. I'm going to calculate that in Jamovi. So for a Pearson's R, we're looking at a linear relationship between two continuous variables. In this case, my research question is there a positive relationship between academic self-efficacy and knowledge about resources available on campus? So what we're looking for, another way to phrase this would be, do students who tend to score higher on academic self-efficacy also tend to score higher on knowledge about resources? So we're using scales to measure this, and so we end up with a number that quantifies their score on these different, their knowledge on these different areas. So the first variable that we're looking at is this academic self-efficacy. This is continuous. And then we have this knowledge about resources on campus, which is also continuous. So we are going to go ahead and look at that in Jamovi. So I'm going to go ahead and switch my screens over. And here I am in Jamovi. And so I'm looking at the relationship between this variable, which is resources. And you can see it's the score on the knowledge about resources at Fresno State scale with a possible highest score of 25, indicating they know a lot about resources on campus. So this is a number and it's set to continuous here. And then we're going to compare that to this academic self-efficacy. So this is a academic self-efficacy scale total score here. So my Jamovi's having a moment. So I'm going to go up to regression. And you can see that it looks like a scatter plot. We're going to go ahead and open this and go to correlation matrix. Now in a different video, I'll talk about checking assumptions for this test. And so I'm going to go to correlation matrix. And I just need to move both of my variables over. Now you'll notice that this is set up where it wants you need to have a numbered variable to do this analysis. And you should really only do it for continuous variables. And so for this, we have it set to Pearson as our correlation coefficient. We're going to add our variables over. So let's do resources. I'm going to move that over. And then academic self-efficacy and move that over. And it's going to give me some information here. Now, this is going to give us the two-sided test for this. So it's a two-tailed test, but I actually wanted to test a specific direction. So I wanted to see if there was a positive relationship. So I'm going to check correlated positively. And so here we can see that we have our information here in this little correlation matrix. Just a note, if you want to do multiple correlations at the same time, so let's say that I also wanted to look at their post-stats score, and I moved that over as well, you can see that it adds to this correlation matrix. And the idea here is that you're looking at where the variables connect. So this right here, this is resources for the column, and then academic self-efficacy for the row. And so this would be the relationship between those two variables. And then we also have resources and this post-stats test. And we also have the relationship between academic self-efficacy and the post-stats test. And that's this right here. So this correlation matrix is going to be just the bottom triangle. The reason for that is that if we were to do academic self-efficacy and resources right here, that would actually be the same thing as going to resources and academic self-efficacy. So this would just be the same number. So we're just going to look at the bottom left side of this. So this is how you would read this information or how you would set this information up. So again, the next video, I'm going to talk about the assumptions for this test and then talk about how to interpret this as well. But that's all that I have for this video right now.